Hello, ma'am. Hello.
Good evening, sir. You are
Yes, sir.
audible. Good
Yes,
evening.
sir.
Yes, ma'am. Yes, ma'am. Good evening, madam. Good evening. Let us start, ma'am.
Yes, sir. You can
Yes,
start.
sir. Yes, sir. Good evening to
Sir,
one and
wait
all
for the
present.
formalities.
Shall I start, ma'am?
Yes, Masuda, you
Mm.
can start.
Good
Yes,
evening to
yes,
one and
Sudha.
all present. Yes, ma'am. One and all present here. On behalf of the management, principal, faculty members, and students of Tasim Bibi Abdul Qadir College for Women and Department of Computer Science, I welcome you all for attending the knowledgeable 5 days faculty development program on research challenges for beginners. Today is the third day of 5 days faculty development program and the topic is cloud infrastructure services and environmental impact of green cloud computing in the domain cloud computing. Prayer is the means of sustaining a faith that at times can grow weak. The power of prayer is enriching, uplifting to hear our Almighty speak. May I now call upon Ms. A. Abu Ashrifa, 3rd BSc Computer Science, to invoke the blessings of the Almighty.
Ma'am, ma'am, my voice is audible.
Yeah, start, ma.
Yes,
Start.
ma.
Okay. Assalamu alaikum wa rahmatullahi wa barakatuhu. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. Amen. In the name of Allah, the gracious, the merciful. Praise to be Allah, Lord of the worlds, the most gracious, the most merciful, Master of the day of judgment. It is you we worship, and upon you we call for help. Guide us to the straight path, the path of those you have blessed, not of those against whom there is anger, nor of those who are misguided. Sadaqallahul Alim. Thank you.
Thank you, Abu Ashrifa. Coming together is a beginning. Keeping together is a progress. Working together is a success. Never neglect an opportunity for improvement. Look for the opportunity in every situation to learn and grow in wisdom. Now, I would like to welcome Dr. P. Sendil Kumari, Head in Charge, Department of Computer Science, to address the gathering.
Thank you, Mrs. Sudha Abirami. A pleasant good evening and a warm welcome to one and all who present here. It's my privilege and pleasure on behalf of our principal ma'am, director sir, and faculty members of Computer Science Department to welcome you all here for today's program. I would like to welcome our resource person, Dr. R. Kartikeyan, Professor and Head, Department of Computer Science and Engineering, Mohammed Sadak Engineering College. We are delighted to have you with us to present in third day of our faculty development program, sir. Thank you for accepting our invitation to act as the resource person for this FDP program. He has completed his PhD in Information and Communication Engineering. His thesis title is An Energy Efficient Task Scheduling and VM Consolidation Approach for Multi-Tenant Cloud Environment. He has 18 years of academic experiences. Then he has published 10 papers in SEI and Scopus journals, then 8 international conference presentations, and he has organized 23 seminars, conference, workshops, and online career guidance programs. He acted as the convener. He has 2 patents published The title of the invention is Intelligent Medical Problems Detection Using Machine Learning Technique. Second invention is Smart Patch for Remote Monitoring of COPD Patient. He was invited as an expert member to deliver technical contents for the participants in AICTE-sponsored 2 weeks online FDP program on ideas and innovations in blockchain architecture technology and its research applications, phase 1 and 2, organized by Saidamal Engineering College, Ramanathapuram. He has delivered a guest lecture on the topic E815 Problem Solving and Python Programming, conducted by Fatima Michael College of Engineering and Technology. He has received funds for organizing International Virtual Conference on Artificial Intelligence and Statistics, AICTE sponsored program. Then he has received funds for 2 national conferences, DRDO sponsored programs. Then he has published 2 books on the title of Problem Solving and Python Programming and Programming in C. He has industry interactions with various companies such as Romesoft Technologies Private Limited, OpenWave Computing Service Private Limited, and Cybergate Technologies Private Limited. Then his academic excellencies, he was appointed as a member of 2021 Syllabus Revision Committee by Anna University in the year 2021. He has received Best HOD and Faculty Award from the Principal and Management during the academic year 2013 to 14. Then he was appointed as a TCA, Testing Center Admin for TCS ION online examination. He acted as the coordinator for various career guidance programs for plus 2 students. He acted as the chief examiner for VAO exam conducted by Tamil Nadu government at Mohammed Sadek Engineering College. We are very much proud to have such an expert with us for today's program. I welcome you, sir.
Thank you, ma'am.
Last but not least, I would like to welcome all faculty members from various institutions. I welcome you one and all who present here. Over to Mrs. Sudha Abhirami.
Thank you, ma'am. It's my pleasure and privilege to welcome Dr. M.S. Irfan Ahmed, Director, Research and Industry Institute Relations, Head Department of Computer Science, to deliver the keynote address.
Sudha, sir told he will not come.
Okay,
He will
ma'am.
join
Okay,
us
ma'am.
later.
Okay, ma'am.
Okay, ma'am.
Next, I would like to welcome the resourceful resource person, Dr. R. Karthikeyan, Professor and Head, Department of Computer Science and Engineering, Mohammed Sadat Engineering College, Kirakarai, to take over the session. Over to you, sir.
Yes, ma'am. Thank you. Thank you very much for your wonderful welcome address. First of all, I need to convey my sincere thanks to the principal ma'am, Dr. Sumya ma'am, and the head of the department, Dr. P. Sajil Kumari madam, and Dr. Irfan Ahmed, the director R&D, and the faculty members of KBAK College for giving this wonderful opportunity as sharing my research thoughts with other faculty members. So once again, I convey my sincere thanks. Now I will share my presentation for this FDP. Ma'am, please give me the rights to present my presentation.
Yes, sir. Sir, kindly send to my mail ID, sir. I will share. if it is not accessible to you.
Okay, okay. I will send the presentation. Huh?
Yes, sir. Yes, sir.
Okay. Which mail ID I will send, madam? Your Chandrakumari madam mail ID. Can I share with the Chandrakumari madam mail ID?
Yes, sir. Yes, sir. Send to me, sir.
Okay.
Sir, now please try with sharing your presentation, sir. I have changed the options.
Yes. Yes. Okay.
Sir, if you don't mind, please send to me one copy, sir. I will try to
Yes.
load.
Okay. Okay. Ma'am, send it, ma'am.
Yes, sir. Yes, sir. You continue, sir. I will upload and inform you, sir.
Okay. Ma'am. No. Madam, presentation is up here.
Yes, sir.
Yes.
Your mobile is visible only, sir.
Okay. Very good evening to all. First of all, I welcome all the participants for this wonderful faculty development program conducted by the GBK College. This is the day three. Uh, my topic is cloud infrastructure services and environmental impact of green cloud computing. So I have to classify this presentation by the category as first one is the cloud infrastructure along with some basic concepts, that is the deployment and service models. Then what do you mean by green computing and what is the need of the green computing and what are the impact of
Excuse me,
green computing? Yes, yes, ma'am.
voice is not clear, sir.
Voice is not clear.
Huh.
Sir, it's audible only. You can proceed.
It's audible, huh?
Yes, sir, you are audible only.
Okay. So the presentation today, the presentation is classified as first one is cloud infrastructure. What is cloud infrastructure? And along with some basic concepts as a deployment model and a service model. Then what do you mean by green computing and what is the need of green computing? And what are the research issues corresponding to the cloud computing environment? And after that, in particular, conversation on the research topic of power management. How to increase the power efficiency of data centers. It's my own research. It's my own research topic. What are the algorithms I have applied for this one? So last one I have explained about those things. So now we have to start with the presentation. First of all, cloud infrastructure service. So what do you mean by cloud infrastructure service? First of all, we know about those things because of the cloud computing is nothing but on-demand computing as well as internet-based computing. So the cloud infrastructure means it will be built up with what are the components. So it will be built up with the hardware and software components such as servers, storage, networking, and virtualization software, and some other services and management tools that support the computing requirements of a cloud computing model. So first of all, we have to take the cloud infrastructure means it will be like a front end and back end tool. In back end, we are having the data centers. In data centers, we are having some set of components. So these components are massive components, not like our computers. These components are massive components, and the capacity of these components are very, very high, huge. For example, in if you are going to take the processor type means it will be a many core processor. Ordinary, we can use the multi-core processor, but in data centers, we can use the many core processor. Then here the data center is the application layer. That means it is the abstraction of virtualized resources. So the resources can be provided by the means of virtualized manner. So we can use in the virtualization layer in between the front and back to then application programming interfaces. That means by use of this application programming interface, the users can interact with the cloud computing concept. Then what are the components of cloud infrastructure? In a cloud computing architecture, the cloud infrastructure refers to the backend technology. Already I explained it, that means the data center. The elements found within most enterprise data centers like servers and persistent storage and networking equipment, but on much greater scale. That means the scale of the particular components are much more big compared to our desktop computers. Some large cloud providers that are called as include hyperscale cloud companies, such like Facebooks and LinkedIn and Twitter. They can using their own data centers, and they are using the much more big size of data centers. So they have to link with the some other vendors for optimized for specific needs such as power efficiency or workload that include big data and AI. Then internet cloud. The cloud also called as the internet computing because there is no internet, there is no cloud. So cloud is always supporting with the internet concept. So the cloud computing applies a virtualized platform with the elastic resources and demand by provisioning hardware, software, and data set dynamically. So the main motive or main objective of this cloud computing is we can using all the resources in a cloud computing by on-demand manner. Suppose if you want to means just you can access the particular resources on pay per use model. That means if you want to, we can use. As well as it is a measuring concept. Suppose if you are using the server for 1 day or 1 week or 1 month, depending upon the period what we are using, we can pay the money. So the cloud computing leverages its low cost and simplicity to benefit both users and providers. As well as the cloud computing intends to satisfy many user applications simultaneously. The cloud ecosystem must be designed to be secure, trustworthy, and dependable. So this is a simple illustration about the cloud computing concept. So in a cloud computing, we are having all type of resources. If it is a hardware, or if it is a software, or if it is a storage, or if it is a network, whatever it may be, it will be available on-demand manner. It will be available in the cloud concept. The users can pay the money and access the service on-demand manner. Then five essential characteristics of cloud. First, cloud is an on-demand self-service. Then second one is there is a broad network access. The bandwidth of the cloud computing is much more gigabytes and terabytes. That means gigabytes per second and terabytes per second the bandwidth it has used. That is a broad network access. Then resource pooling. Here everything will be virtualized manner, so we can able to access the virtual pooling of resources and drive it elasticity. That means scale up and scale down the resources what we need. For example, I need 10 server means at the time we can use the 10 servers. Then sometimes I need a low count of servers I need means it will be reduced. Scale up and scale down. That means rapid elasticity. That means scale down and scale up the resources, but the performance efficiency will be same. Then measured services, everything will be measured. That means what amount we are going to access the cloud resources, how much of month and how much of time or how many hours we can access the particular resources. Just we have to pay for that particular time only. That is a major benefit of the cloud computing concept. So this cloud computing can be categorized into two main concepts. That is the deployment model and service model. So what do you mean by deployment model? Means a cloud deployment model is defined according to where the infrastructure for the deployment resides and who has control over that infrastructure. And each cloud deployment model satisfies different organizational needs. So it's important that you choose the model that will satisfy the needs of your organization. So we have to deploy our phone. That means what kind of service we need. If it is a software, if it is a hardware, or if it is a application oriented. So we have to deploy as our own wish. Then cloud service model. Which type of service they are going to access? Which type of service? That is called a service cloud service model. The term cloud service refers to a wide range of service delivered on demand to companies and customers over the internet. These services are designed to provide easy, affordable access to applications and resources without the need for internal infrastructure or hardware. So this is a simple illustration about the cloud deployment and service model with the essential characteristics. So we are having three service models. They are software as a service and platform as a service and infrastructure as a service. And we are having the three deployment models: one is public cloud and private cloud and hybrid cloud, and one more is community cloud. And five essential characteristics: they are broad network access, rapid elasticity, and method services, and demand self services, and the support. So these are the five. essential characteristics of cloud. So we are having mainly we are having three deployment models like public cloud and private cloud and hybrid cloud. So public cloud is nothing but the public cloud allows the system and services to be easily accessible to the general public, and anybody can access the services, and there is no need of any restrictions. So so it has a less secure because of its openness. For example, our Gmail and our Yahoo Mail. So all the mail servers can using the cloud concept only. Then private cloud, it is a private things. Then it allows the system and services to be accessible within an organizations. It offers increased security because of its private nature. Then community cloud is nothing but the particular community people. For example, the Python community or Java community. So the community consisting of a set of peoples. So they have to share the knowledge between them. So they can use their own cloud. So the type of cloud is called as community cloud. Then hybrid cloud is nothing but it's a collection of the combination of public and private cloud. For example, if you are going to take the Amazon Web Services and Microsoft Azure, they can using the public cloud as well as the private cloud at the same time. So the type of clouds are called as hybrid cloud. The hybrid cloud is nothing but a combination of public and private. So according to the service models, we are having three service models like infrastructure as a service and platform as a service and software as a service. So we can access the cloud resources on the basis of service model. If you are going to access the hardware resources like disk storage or processor or virtual processors or network bandwidth or IP address, whatever it may be, corresponds to the hardware resources, that is under the category of infrastructure as a service. So the infrastructure service is the most basic level of service. Each of the service models make use of the underlying service model, that is, each inherits a security and management mechanism. From the underlying model as shown in the diagram. So for example, if you are going to the IaaS, it's underlying structure. That means what are the hardware supports, that hardware resources which will available in the underlying concept of cloud computing. Then platform as a service. So we have to interact with the cloud infrastructure by use of the platform. That means which platform is used to interact with the cloud resource. That means infrastructure. Then application. So application under the category of software as a service. These three things can be illustrated in this figure. In underlying structure, infrastructure as a service, the middle platform, and the top application. Then infrastructure as services is a way of delivering cloud computing infrastructures like server, storage, network, and processing elements as service and demand. So apart from these resources, the IaaS also offers virtual machine disk storage. So virtualization concept is one of the backbone concept of data centers as well as the cloud computing. Because of the virtualization concept will be used to make the more resources for cloud users. So it's which also provides a virtual machine disk storage and a virtual local area network, then load balancer, IP addresses, and virtual network, whatever it may be, everything will be provided by this infrastructure as a service. Then this figure shows how the infrastructure as a service will be delivered to the users. All of the above resources are made available to end users via server utilizations. So the resources are accessed by the customers as if they are owned them. For example, the software owner can create everything. That means to the virtualization as well as the server virtualization, processor virtualization, network virtualization, everything will be decided by the admin and it will be provided by the users. The users can access all those things via the firewall and load balancer and accessing the particular resources through these components. Then what are the merits and demerits of these infrastructure services?
Hello.
Hello. Then what are the benefits? So it has the full control of the computing resources through administrative access to virtual machines. Then it's a flexible and efficient renting of computer hardware, and it has a portability and interoperability. That means interoperable concept for in a distributed environment, the interoperability is a must. So there is no need of any configuration level restrictions, and there is no any configuration level hurdles. So everything will be solved here. And portability, we can transfer our content from one place to another place easily. As well as it's a flexible and efficient renting of computer. There is no need of purchasing the high level hardware. Instead of that, we can accessing everything will be on demand. That means hiring methods. Then we are also facing some of the issues. They are compatibility with legacy security vulnerabilities. Then virtual machines travel. For example, if you are going to create more virtual machines, handling of the virtual machine is one of the DDS tasks. So there is no best data erase practices. Whenever the data consistency may be occur, if you are creating the, you can storing the data, then again the erasing practices is not clear in the cloud infrastructure as a service. As well as the VM level isolations can be occur. So we must face all these issues in a cloud computing concept. The next one is the platform as a service. The platform as a service provides a runtime environment for applications. By using this platform as a service, we have to deploy our own applications as well as the applications already available in the cloud computing. So, for example, the Google App Engine, Salesforce.com, everything will be uh, used for this purpose only. And this platform as a service, IDE will be used to integrated development environment is used to creating our business applications, and the business users can access the applications. So the developer can create the application. And platform as a services also having some benefits as well as issues. They are lower administrative overhead and lower total cost of ownership, then scalable solutions, and more current systems. Up-to-date current system software will be available. Scalable solutions. If it is, we are having some problem with applications, we are able to solve the problem easily. Then some of the issues we have to face here is lack of portability between platform as a service clouds. Then security engineering of platform as a service application. Security is one of the major issues in cloud computing concept. Then software as a service. Here they have to consider the software is billing and invoicing system and customer relationship management and help desk applications. So here the major application softwares are available. If you are going to purchasing this type of software means we are spending more money for this purchasing. So instead of that, we are able to purchasing these application software in a rental basis, that means hiring basis. So here we are having some of the benefits belongs to the software as a service of modern software tools, then efficient use of software licenses, and centralized management and data, then platform responsibilities managed by providers, multi-tenant solutions. Uses what we have to face the browser-based risk, network dependence, and lack of portability between SAS clouds. And what are the pros and cons of cloud computing? The cloud computing is the cost savings. We are spending less amount of money if you are going to setting up the high level hardware, and it's a reliable and manageable. Then it's a easy access of information, and we are able to deploy quickly. It's a streamlined process and disaster recovery. If it is the problem will be after the server will be crashed. We have to access the same data from any other places because of the backup and recovery from here. Then increased collaboration and environmentally friendly. Um, at the same time, we are having some of the disadvantages. The main major disadvantage of cloud computing is downtime. That means the server is down means they are not able to access the cloud services. That is the main disadvantage of cloud computing. For example, in 2010, per minute downtime cost uh, 5,600 US dollar. Now it will increase as $7,600 per minute. So the total cost consumption in 2010 nearly 5,50,000 US dollar, but now it becomes 41% increase. Now the total downtime cost is 69 lakhs 200 US dollars. Then second disadvantage what we have to face here means security problem and vendor login. The cloud services will be available in different vendor. For example, Amazon web services there, and Microsoft Azure, Salesforce.com. Lot of vendors are there. If you are going to access with the different vendors, it is one of the difficult process, vendor login, and the limited control. Some of the control will be limited for the users. So that is one of the issue. The next concept what we are going to discuss here, the green cloud. The green cloud concept is one of the important main concepts what we are going to today. Because of today, the data center will be increased more, and high power consumption increased through the data centers. So the green computing as well as the green cloud is one of the important concepts for our computer people. So the cloud computer has become an essential infrastructure demand for a modern organization for several reasons, covering scalability, security, and cost effectiveness. However, this ever-growing demand has also resulted in elevated energy consumption level, which has ultimately bolstered the environment's carbon footprints. Through the data centers, much more carbon emissions will be emitted, so it will be make the global warming. As more and more data centers are added to the organizational realms, they will require thousands of servers and other necessary materials to enable a full-fledged operation. Since it leads to serve environmental damages, the concept of green cloud computing seems befitting to such modern and future scenarios. So what is green cloud? So green cloud computing involves designing, producing, and using digital spaces in a manner to reduce this impact on the environment. A green cloud solutions cannot only save energy, but significantly reduce enterprise operational costs. The green cloud computing allows users to utilize the benefits of cloud storage while decreasing its adverse effects on the environment. It includes the following practices, that is green design and green production and green usage. Whenever we are going to consider these three factors, we must reduce the uh, uh, we must increase the green computing concept as well as reduce the impact initiated by the over power consumption. So the green designs is belongs to the cloud infrastructure design covers energy efficient services, computers, software applications, and other devices that consume reduced energy than its counterparts. Then what do you mean the green production means? The cloud infrastructure generates less waste during the recycling exploitations, resulting in a more sustainable environment. Then green usage is one of the important things. That means it reduces the amount of energy produced when using a cloud-based product by a 27% more. Then what is the goal of green cloud computing? The goals of green cloud computing are plans to reduce the use of hazardous materials. Then second one is maximize the energy efficiency during the product lifetime. Then third one is promote the recyclability. Then fourth one is making the use of computers as energy efficient as possible. The designing the algorithms and system for efficiency related to computer technology. So there are several approaches to green computing. They are product lifetime. First of all, we have to increase the product lifetime. So we must ensure the green cloud computing as well as algorithmic efficiency. We have to develop the algorithm for reducing the power consumption of the data centers and power consumption of the computers. Then resource allocations, how to allocate the resources in efficient manner. It will be reduce the power consumption as well as to increase the green computing concept. And virtualization, we can applying the virtualization in efficient manner, we can ensure the green cloud computing. Then we can handling the power management in a efficient manner. So these five is a very important. One is product lifetime, algorithmic efficiency, and resource allocation, then virtualization and power management. So this figure illustrates how the green computing will be achieved. It will be based on uh, resource management as well as the sustainable resources. These two are the important thing to ensure the green cloud computing. The resource management is depend upon the concept of virtualization and effective scheduling and effective replica management and effective usage of power and voltage scaling. And the sustainable resource is under the category of heat reuse and sustainable energy and free cooling. Then cloud computing is the one of the important another part or important thing and the key concept of uh, data center. Because of the cloud computing will be initiated by the concept of data center. Cloud computing is a front end and back end what we are going to provide the resources in which place we can provide the resources for the cloud computing needs. Everything will be provided under the category of the data center. The data center is the backbone concept of cloud computing. By using the data centers, we have to provisioning resources to the cloud users in effective manner. So that the data center is one of the important concept or backbone concept of cloud computing. The data centers are designed to house information system. It is also called as house information system, which consisting of the servers and collection of servers, collection of routers and storage and uninterrupted power supplies and cooling units and power distribution units. So that is which is called as house information system. The data centers have unique and typically large power requirements, so that it will be producing more, it will be consuming more power because of which consisting of thousands, hundreds and thousands of servers. Depending upon the size of the data centers, if you are going to take the Google or Facebook, they can using the data centers like a village. So which consisting of nearly thousands of servers. These servers can consume more power, and these servers can emitting more carbon emissions. So it will be affect the global warming. Then it will be initiate the global warming concept. As well as it requires specialized equipment and knowledge. It will be operated by the specialized peoples. Then it's a highly adapted and it is a key concept of key component of cloud. So these are the data center components. That means the data centers. In data centers, we are having the servers, storage, and networking, and infrastructure, and environmental monitoring, and the cabling, and backup power, cooling concept, software. Everything will be belongs to these data centers. So that is it will be called as the house information. The power consumption by data center equipment. The data center equipment's power consumption can be classified as three major categories. That is, cooling system. Other than the IT equipment, cooling system can consume nearly 45% of overall power consumption. Then IT equipment can consuming nearly 40% of overall power consumption. And power distribution. During the power distributions, it will be nearly lost 15% of power will be lost during the power distribution. So it consuming nearly 15%. So the power consumption by data centers can be classified as this uh, concept. That means the cooling system can consume 45%, IT equipments can consume 40%, and power distribution 15%. In our research work, we are going to focusing in this IT equipment concept. Because of this cooling system, we are not able to reduction the power consumption because of everything will be here AC machines and cooling ventilation machine AC. Everything will be belongs to the mechanical department. So we are not able to handling those things. So we are able to only handling the IT equipment, 40% of IT equipment. In this 40% of IT equipment power consumption, how we have to reduce the power consumption of this 40% IT equipment? That is the research concept of ours. The power consumption, these 45% can be classified as follows. That means the power consumption by server components can be categorized as 60% of power consumed by the processor and RAM. That is, CPU and RAM can consume nearly 65%. Then storage, this storage can consuming nearly 21%. Then other equipment can consuming 5, and networking consuming 9%. This is the overall power consumption of IT equipment. Here the major contribution is processor and RAM. So we are giving the more concentration on this processor and RAM. So our narrow view of this cloud research concept is we can concentrate our research concept on this processor and RAM. How we are going to reduce the power consumption of the processor and RAM of this cloud data center. So this figure illustrates the relationship between the utilization versus power consumption of server components. So it can be compared with the power consumption with the physical machine utilization. Whenever the physical machine utilization is increased as 100% of utilization is achieved, at the time 80% of power consumed by the CPU, and this can consume nearly 70% of power consumption, and others can consuming nearly 55%. So whenever we have to increase the utilization level, the power consumption level also increase. So there is a illustration of this figure. Then power management. Power management is one of the major concept of data centers as well as cloud. The power management in cloud system allows users to control the amount of power consumed by underlying devices with the minimal impact on performance. That is very, very important. What are the challenges of power management? What are the challenges we have to face during the power management concept? So first one is massive energy consumption. So each and every IT equipment, in especially the processor, that means the CPU, can consuming massive power energy consumption. Then server overload issue. Sometimes server will be overloaded, sometimes server will be underloaded. So these two are the important issues. We can face the problem while the server is overloaded. At the same time, we are facing the problem while the server is underloaded. So these three things are one of the major challenges we are facing during the power management concept. Then significant process involved in power management, or what is the concept we are going to applying to reduce the power consumption? That is VM consolidation, effective VM consolidation, and effective VM migration, and effective task scheduling. VM consolidation is nothing but we can fix or we can hold the VM virtual machines in a correct physical machine, and how to consolidate. How to consolidate means how to hold or how to fixing the virtual machines on correct physical machine. That is the concept of VM consolidation. Then VM migration means sometimes we need to migrate a virtual machine from one physical machine to another physical machine. Due to some overload or due to some underload concept, we should use this concept. That means we can transfer the VM virtual machine from one physical machine to another physical machine. That is the one of the major thing. That means a major solution to overcome the problem. Then task scheduling. The task we can schedule the task in effective manner. It will also reduce the power consumption. Then what is the impact of high power consumption of cloud data center? If it is the data centers can consume more power means what is the impact in the what is the environmental impact of this over power consumption? That means all the data centers are predominantly occupied by low cost underutilized volume of servers. So, for example, if you are going to take the Microsoft is adding 20,000 servers monthly to their servers. It's a report of 2010 report. Monthly, they can add 20,000 servers in their data centers. As per the report of EPA, that is the Environmental Protection Agency at USA, they have to produce the report as data center consumed 1.5 percentage of total US electricity consumption for a cost of $4.5 billion. So the overall electricity consumption of US, from that nearly 1.5 percentage is consumed by the data center itself. So the energy cost continues to double every 5 years. They will substantially increase to 1,600 percentage between 2005 and 2025. The substantially increased up to 1,600%. So as per the McKinsey report, research report says that carbon dioxide emissions from data centers, like carbon dioxide emission is one of the major impact of global environmental impact of global warming. So, from data centers around the world is 2 times of emission in the past, and which is equivalent to total entire aviation industry. And now we are going to a narrow uh, approaches. That means the hierarchical approach of research is used in cloud computing. What are the research issues? For example, the faculties we are going to take the going to do your research on the cloud computing means which topic we are going to take and which concept is adapt for your research. That is very very important. So if you are going to do your research means lot of cloud concepts are available. First one is elastic scalability. While we are going to increasing the servers or decrease the servers, what will be happen, and through this how we are going to do our research. That is the elastic scalability is one of the concept. Then security and privacy. Security privacy is one of the available research issues in cloud. Then energy efficiency is now we are going to discuss about those things. Energy efficiency, that means to increase the energy efficiency of data centers and to decrease the power consumption and to ensure the power efficiency as well as to decrease the power consumption of the data centers. Then system development and management, then handling of data in cloud, data storage. So we are able to do the research on the data storage in cloud. So these are some of the research issues correspond to the cloud computing. We are able to do the our research in the particular any one of the particular areas. Then software in energy efficiency is our research work. Energy efficiency, we can ensure the energy efficiency or improving the energy efficiency of cloud data centers. What are the methods we are going to apply? By using this method, how we are reducing the power consumption of data centers, in what kind of methods we are using. That is the important thing. So that is the things we are going to discuss here. This energy efficiency can be categorized as software approach and power allocation and workload distribution. In my research, what I have to focus means dynamic voltage frequency. In distribution, we are having two methods. One is dynamic voltage frequency, is simply called as DWS. It will be more focused on the gate level circuits. We have to focus on the gate level circuits, how the power will be reduced. By using this method, we are able to only reduce the less amount of power consumption. We are able to reduce only less power consumption. If you are going to take another one is dynamic service pole resizing, that is called as DSPR, dynamic service pole resizing. That is by using applying the virtualization concept, we can achieve our power efficiency. That means energy aware heuristics approach. So that is the research concept I have focused. So that is the more narrow view of my research work. That is the power management technique can be classified as two things. One is the static power management technique, another one is dynamic power management technique. In the static power management techniques,
we are having two methods. One is hardware level, another one software level. In this software hardware level, we are having three things. One is the circuit level, logical level, and architectural level. So we can applying the methods on those level and reducing the power consumption of the data center. But already I told the method used here is very less amount of power only, power efficiency only we have to achieve. If you are going to achieve more power efficiency, we can take the dynamic power management. In this dynamic power management, we are having two methods. One is hardware level, another one is software level. In the software level, we are having two methods. One is a single server method, another one is multiple servers. If you are going to take the data centers, it's consisting of multiple servers. So we can focus on the multiple server concept. In particularly virtualization level, that means all the servers are virtual pool of resources. So every servers, for example, if you are having only 10 servers, means these 10 servers can be act as 100 servers by the support of the virtual machine concept. So we have to focus in this virtualization concept only. So what is power management? Static power management. The static power management techniques are applied in logic gate level, circuit level, and architecture level. The static power management contains all the optimization methods that are applied at the design time, at the circuit, logic, architectural, and system levels. The static power management includes more complex designs in the management of power. So the circuit level engineers can only take the opportunities to do the particular thing of research. So one is a tedious and a complex system of research here. The dynamic power management is nothing but it's a technique that include methods and strategies depends on runtime behavior of system. That is very important. The static power management only not in the runtime. So if you are going to applying the runtime, that is the best system to reduce the power consumption. So the DPM can be applied in the runtime management, runtime behavior of system according to current resource requirements. The major assumption enabling DPM is the first assumption is two assumptions have to taken here. The first assumption is that the system dynamically adjusts the power states according to the current performance requirements. What is the current requirements of the power consumption? Depend upon the current scenario, it will be scale up or scale down the resources what we have to provide by the support of data centers. That is the first thing. Then second assumption is that the workload can be predicted to a certain degree. The workload can be predicted where the higher workload will be going and where the lower workload will be going. That means we have to fix the threshold value or threshold limit of the particular resources. That is second thing. The dynamic power management algorithm is concentrated in this in my research work. Dynamic uh, dynamic algorithms only we are already focused. Then what are the power management approaches are available? For example, in a dynamic manner, what are the power management approaches are available? So these approaches taken by the reference papers already they have to publish in more reputed journals. So first one is hardware-based approaches. Then second one is energy-aware resource consolidation. Then third one is heuristic-based approaches. Then fourth one is energy-efficient task scheduling approaches. These four approaches are available in a dynamic power management techniques. Then hardware-based approaches. In a hardware-based approaches, lot of methods are already available, and these methods are focused in more journals. Some of the methods here focused are dynamic voltage adjustment method, non-intrusive method, then auto-regressive integrated moving average model, and resource regulation of dynamic voltage scanning, and heuristics algorithm. These are the more famous hardware-based approaches available in the SC indexed journals. That means existing approaches. Then second one is energy-aware resource consolidation approach. So these are all the existing technologies already delivered. That means a modified pin packing problem is on the base thing. Then power-aware application placement framework, that is simply called as PMAPR. Then limited look-ahead control, simply called as LLC. Then multi-objective optimization approach. Then dynamic VM consolidation and proactive application-centric VM allocation. The next method is heuristic-based approaches. These approaches can be derived from the existing methods. That means these methods can be derived. What are the techniques already available? From that techniques, you have to derive the new techniques. That is called as heuristic-based approaches. Here, some of the existing technologies are available that are linear regression and k-nearest neighbor regression. That is simply called as KNN. Then heuristics techniques and migration control, and novel workload consolidation algorithm based on ACO. Then reinforcement learning based dynamic consolidation, that is oral DC. Then energy efficient task scheduling approaches. Here we are having some of the algorithms, that is under the category of meta heuristic scheduling algorithm. Genetic algorithm is there, and iron colony optimization is there, particle swarm optimization is there. Then Firefly algorithm and hybrid meta heuristics algorithms also here, as well as the minimum energy virtual scheduling algorithm, min-ES and min-CS, minimum communication virtual machine scheduling algorithm, min-CS and min-ES method, and DVFS enabled energy efficient workflow task scheduling also available. So these are the methods. In my particular research work, what I have focused means VM consolidations and VM migration task schedule. I have to focus my research work focused on these three things. That means the efficient VM consolidation and efficient VM migration and effective task scheduling. By using these three methods, I have to reduce the power consumption of data centers and increasing the power efficiency of the data center. Then, first of all, auto scaling techniques. First one is the basic concept of my proposed work. I have to design a green cloud architecture. In this architectures, I have to use some of the components. By using this component, basically, I have to reduce the power consumption of the resources. So the first and basic concept is auto scaling technique. The auto scaling is nothing but its ability to automatically scale up or scale down the number of computing resources what we need to execute the user request. So auto scaling is mainly used to increase the server utilization and decrease the ideal time of service. For example, if you are going to the most of the data centers, most of the servers in the data center is underutilized mode. That means most of the servers in the data center, their utilization level is below 10%. That is the fact of today's data centers scenario. So the decreasing ideal time of server and increase the server utilization, that is the main objective of the auto scaling. Then in existing auto scaling techniques, not able to provide better performance due to local fluctuations. So in my research work, it was overcome. In order to overcome this problem, an auto scaling technique, we have to fixing a queue, that means containing pre-booted virtual machines, pre-booted as well as the pre-configured VM instances. VM instances means virtual machines. We can using the pre-booted and pre-configured virtual machines. It will be located in the auto scaling queue. When cloud applications request a new VM configuration from auto scaling framework, it is used to satisfy the request with the pre-booted VM in the framework. For example, if the VM with Windows, Java, EE, and MySQL is requested, the scalable framework will attempt to find a matching VM in the pre-booted list. If it is not available, it will be go and access the server. 90% the user request will be satisfied with the auto scaling. That means a pre-booted virtual machine. Sometimes it is not possible. The particular combination is not available, means it will be go and access the particular things from the physical machines available in the data center. Then one more concept what we have used in our research work means Achieve model. The proposed architecture framework uses Achieve model to manage the difficult catalog of VM configuration and also manages the complexity of representing VM configuration. That manages blueprint for user request to VM instance configuration as well as checking its correctness in effective way. So the Achieve model will be used to create our pre-booted virtual machines depend upon the previous user request. So previous user request, we have to make our own archive model. So it will be used to the blueprint of the user request. So the archive model uses a tree structure of define the relationship between the various attributes and encode configuration rules into model. So this is the proposed green cloud architecture framework. This framework consisting of some set of modules. The first thing is cloud applications. After that, green resource allocator will be available here. In this green resource allocator, we are having a set of modules. They are green negotiator, service analyzer, consumer profile, pricing, energy monitor, service scheduler, VM manager, and accounting. So these all the modules under the category of green resource allocator. So in between the cloud center resources, here the cloud center resources are available in the underlying structure. That means all the resources like servers, storage, network, everything will be available in the low level category. That means the underlying architecture. From these underlying servers, from the virtual machines, we have to take some pre-booted, pre-configured virtual machines. We have to take some pre-booted and pre-configured virtual machines. It will be located in the scalable framework that is already I have explained. The scalable framework that is called as auto scaling technique. This technique already used in the Amazon. This scalable framework consisting of pre-booted and pre-configured virtual machines. These virtual machines will be used to fulfill the requirements from the users. Sometimes it is not possible. At the time, it will be go and access the resources available in the physical machine in the data center. So this green resource allocator is one of the important thing. Then these are the modules. The modules will be explained here. The service analyzer. What is the use of service analyzer? It is used to analyze submitted request condition, whether it is accept or not based on the current load and energy. And what is the use of the consumer profiler? It will be used to analyze the consumer profile and granting special privileges and priority over other consumers. And energy monitor will be used to an energy responsible for power management of the physical machine. Then VA manager is the overall control of all the virtual machines are available in the physical nodes. Then accounting is used to actual usage of resources by VMs and cost of resource usages. Then virtual machines, it is the main part of the cloud data centers because it is one of the active participants in the virtual physical machines. It's one of the active participants to fulfill the user's request. That means the multiple VMs can be dynamically started and stopped on a single physical machine according to incoming request. Multiple virtual machines with different configurations can currently run applications based on different operating system environment on a single physical machine. The physical machine is one of the active module of cloud data center. It is an underlying concept of cloud computing that provide hardware infrastructure to create virtualized resources for responding the application request. And VM placement, one of the important thing of my research work is VM placement. Because of the effective placement of virtual machine is to reduce the more power consumption of the virtual machines, as a more power consumption of the physical machine. So the VM placement is one of the important concept in power efficiency. The VM placement in cloud computing is very important operation. It is conducted to determine the most appropriate physical machine or server for the VM. For example, the VMN is here means where we have to accommodate. That is very, very important. We have to accommodate the virtual machine, correct virtual machine, correct physical machine. 50% of power efficiency will be achieved here. Then selecting suitable host is significantly improved power efficiency, resource utilization, and quality of service in cloud infrastructure. The main objective of VM placement is to minimize the VM traffic and reduce the power consumption and decrease the ideal servers. So, to achieve the power efficiency and improve the resource utilization, two significant processes should be involved. That is placing the VM on suitable server and VM live migration process. First of all, we have to fixing the VM on correct physical machine. From these illustrations, from this figure, we are having in upper part we are having some set of virtual machine. In lower part we are having some set of physical machine. Now we are going to fixing this virtual. Sorry. Now we are going to fixing this virtual machine on the correct server. That is the VM placement process. Then VM live migration. That is one of the important. VM live migration is at the time of running time, at the time of executions, we are able to transfer the virtual machine from one physical machine to another physical. It is that is called as live migration. Live migration is nothing but we are able to transfer the virtual machine from one physical machine to another physical machine at the time of running. That is very, very important. The VMs are migrated lively without disturbing the application running on it. That is very, very important. That is the one of the main concept of virtualization. We are able to transfer the virtual machine from one place to another place without disturbing the running on application on the particular virtual machine. So the main benefits of VM migration include it will be used to conservation of physical server energy, then fault tolerance and load balancing among the physical servers, then preventing the performance degradation of applications. So this is the one of the live migration. This figures one of the example of live migration. For example, you have to consider here we are using nearly 5 machines, physical machines. In each, in upper part, each physical machine contains some virtual machine. In physical machine 1, we are having only one virtual machine. In 2, we are having one. In 3, we are having 2. In 4, we are having one. And 5, we are having one. Here, the utilization level of physical machine 1 is 35, physical machine 2 is 25, and physical machine 3 is 50, 4 is 20, 5 is 10. Here, all the physical machines are underutilized. So, what we are going to do here is we have to transfer some physical machine to from one physical machine to another. Here, the virtual machine 3 and 8, that means available in 2 and 5. It can be transferred to 1. And the second physical machine and fifth physical machine is going to ideal state. At the same time, the virtual machine available in 4 physical machines transferred to third physical machine. Now the fourth physical machine going to ideal state. So now it can be viewed as the second, fourth, and fifth physical machines are in ideal state. At the same time, the power consumption of second, fourth, fifth servers are saved. That means they are in ideal state. The power consumption is very, very less. So by using the effective utilization of this VM placement, we have to increase the power efficiency. That means effective placement of virtual machine as well as effective transfer of virtual machine from one place to another. Okay. Then cost of live migration. So how much cost we are going to spend for this live migration is very, very important. The live migration of VMs allows transferring VM between physical nodes without suspension and with a short downtime. And the cost of live migration is given in accordance with the system performance. It is divided into two parameters such as total migration time and what is the downtime it will be taken. Total migration time, how much time it will be taken for transferring from one physical machine to another physical machine, how much of time it will be taken. Then what is the downtime of and how much of time the particular VM is not able to access. That is called as downtime. Particular time the virtual machine or the physical machine is not able to access by the user. That is called as the downtime. So both the combination of these two times is the cost of live migration. The unneeded VM at the same time, we should know or we should consider some of the things that means unwanted live migration may cause us some SLA violations. We can consider the live migration should be in meaningful. If it is, we have to migrate the virtual machines unwanted means it will make some SLA violations. That means a service level agreement. sometimes the particular service is not satisfied by the resources to the users. So it will be arise the service level agreement violations. So at that time, we should consider the unwanted live migration should not be initiated. It is necessary to minimize the number of virtual machine migration. The length of the total live migration depends on total amount of memory used by the VM and available network bandwidth. The length of the total live migration depends on total amount of memory used by the virtual machine and available network bandwidth. That is important thing. Then what are the challenges we are going to face at the time of live migration? That is very important, because of the live migration is not a simple concept. We have to consider a lot of things during the transfer of virtual machine from one place to another place. So what are the challenges we are facing during the time of live migration? First one is VM consolidation, optimizing VM migration according to the utilization of multiple system resources. That is, the selection of threshold value is significant. We have to fixing that threshold value of the servers. What is the upper threshold value? What is the lower threshold? If selected the threshold value is high, then the migration shows better performance result and it shows minimum drop in power consumption. At the same time, if selected threshold value is lower than the consolidation, would not perform effectively. So that so we must consider the threshold value is very must. The optimization of network topologies. Then second one is optimization of network topologies. The additional energy consumed during the process of VM migration. Before initiating VM migration, reallocation controller has to ensure the cost of migration does not exceed. So we must consider the network topologies and reallocation process. Then third thing is VM configuration constraints. Selection of pre-booted virtual machines in scalable framework is difficult. Amazon EC2 cloud infrastructure supports 5 different types of processors, 6 different types of memory configuration options, and several operating system types. The power consumption of these configurations ranges from 150 to 610 watts per hour. So they can consuming this much of range of power consumption. So what are the metrics we are going to take to evaluate our system? So evaluate our live migrations. That is called as performance metrics. The performance metrics is used to evaluate our system. The first metrics is total power consumed by the physical resources. What is the power consumption amount of physical resources? The power is the rate at which the system performs their work, while energy is the total amount of work performed over a period of time. Then second one is SLA violations. So SLA violations should be avoided. So the SLA quality of service requirements are important to ensure the system performance that is commonly formalized in form of SLA. SLA violations occurs when a given virtual machine is not able to get the amount of resources that are requested. That at the time the SLA violations will be arised. The time needed to perform VM live migration. So how much of time we need to perform the VM live migration? That is very important. Then VM migration algorithm is also responsible for managing the time and categorizing the memory access pattern of each running workload effective. Then response time. Response time is defined as the amount of time required to respond the process of user's task, which depends on both VM migration and CPU utilization. So these are the performance metrics we have to take to evaluate our system. The next what we are going to discuss in the particular. So we have to increase the resource utilization with energy aware VM consolidation. Here the energy aware VM consolidation is consisting of energy efficient resource consolidation approach is designed to optimize the energy consumption, increase resource utilization, improves quality of service, ensures desired SLE. Then this consolidation approach has two energy aware algorithm in our research work, that is the VM placement algorithm, VM live migration. By using these two my algorithms, you have to reduce the power consumption of the data center. Then custom virtual machines are placed in your appropriate servers and to perform VM migration according to the CPU threshold limit. Then here the layered approach of cloud structure. The layered approach contains 5 different layers. They are the application layer, cloud service layer, data center layer, cloud management layer, and hardware resource layer. These layers are used to improving the power efficiency, resource utilization, quality of service, and ensure desired SLA by using efficient VM consolidation algorithm. So these are the 5 different layers. These layers consisting of first one is application layer. The application layer is used to define the host type and define the VM type and define the application type. And a cloud service layer, it will be used to provide the services. So it can be managed the quality of service monitoring. That means if it is any SLA violation will be arise. Then energy consumption monitoring and VM provisions to applications and data center layer. Here we can using the VM placement algorithm and VM migration algorithm and 3 CPU utilization threshold value. Everything we have to fix here. Then only it will be by using these algorithms, we have to reduce the power consumption of data centers. Then cloud management layer. In this layer, we are having 3 important functions. They are VM manager and physical machine manager, VM manager, and network manager. By using these managers, we have to effectively manage the virtual machine and physical machine and network bandwidth. And for hardware resource layer, it is underlying layer. It will be available in the underlying structure. By using this hardware layer, which consisting of disk storage and different servers and routers and all the network related elements are available here. And already we were discussed the VM placement. What do you mean with VM placement? Means effectively place the virtual machine in the effective physical machine. So, and we can using some algorithm for this. And enhanced power reduction in multi-tenant cloud. Here the power consumption is initiated. Power consumption is initiated by power efficiency is initiated by the effective task scheduling in the cloud. The effective task scheduling is used to reducing its execution time and increase the power efficiency and improve the resource utilization. So we can using some of the modules to handling those things. The modules are queue manager, scheduler, VM allocator, VM manager, and VM power manager. So this is the illustrations for the system architecture for task scheduling. The queue managers can separate the task into different queue. One is urgent queue and on a waiting queue. In the urgent queue, we are having the short length of task, and it will be go to the scheduler and scheduler scheduling this short task to the VM accommodator, and VM accommodator send the task to the VM manager, VM a virtual machine manager, and virtual machine handling those tasks, and it will be executed, and again it will be go to the VM power manager. So these are the illustrations. And what are the parameters involved in the task scheduling means we have to consider 4 parameters. One is task length, CPU utilization, memory utilization, IO intensity. These 3 things. Task length is important. How much of CPU utilized for the particular task, how much of memory we can occupy for this task, and how much of IO intensity needed to execute the particular task. These are the important thing. And queue manager is handling the task, and it can be divided into 2 important things. That means waiting queue, another one is urgent queue. Based on this, we have to schedule the task and task allocation by VM allocator, then power management by VM power manager. So everything will be handled by the task manager only. The performance analysis is based on the performance analysis. Here we have to focus to the cloud simulator is used to execute our research work. The cloud sim is one of the efficient simulator. Why we are choosing this simulator means it has provide lot of features for the power efficiency research. That means here we can using the cloudlet creation. That means the cloud task creation, energy optimization platform, and load balancing platform, and resource provisioning platform, and task scheduling platform. Everything will be inbuilt in this cloud simulators. By using this, we have easily executed our task. And my research paper was published in 2 science citation index papers. One is Springer cluster computing, and it will be in the Springer, and the impact factor is 1.5. It is one of the famous science citation index journal in the Springer. Another one is paper title is Energy Aware Virtual Machine Consolidation of Cloud Data Center. It was published in the International Journal of Applied Engineering Research, and also it was published in one of the IEEE Explore digital library by the title of Novel Heuristics Energy Efficiency Approach for Cloud Data Centers. For my research, I have referred a lot of science citation index journals and the more reputed journals for my research. These are the journals I have referred for my research work. Madam?
Yes, sir.
Yes, ma'am.
Thank you, sir. Thank you very much for your wonderful presentation, sir.
If there is any query, ma'am?
Yes, sir, definitely. Proceed to Mrs. Sudha Abirami.
Participants, kindly ask your queries, unmute your mic or post in the chat box. Participants, is there any question?
Sir, actually, I have done my thesis in cloud computing only, but
yes.
I have taken the topic as integrity proofs, sir.
Integrity?
You are telling about power consumption, green computing and all.
Yes.
Here you have tell about some virtual machine allocation, sir. Is it similar to operating system page replacement technique and algorithms?
So in your research work?
No, sir. I'm asking only about your research work. You have
system.
told about some virtual machine, sir. Virtual machine usages concept.
Yeah. Because of the virtual machine is one of the key concept of cloud data centers. Because of in cloud data centers, we are having 100 servers means it can be act as 1,000 or 10,000 of servers by using the concept of virtualization. So the virtualization is the key concept. So we can focusing on the virtual machine means it will be more useful to reduce the power consumption. Then only we can focus on the virtual machine. But your question is what, ma'am?
You have told in one particular diagram optimal usage of virtual machines, sir. You have shown some live demo.
Yes, ma'am. That means a live migration from one physical machine
live
to another.
migration.
Yeah. Because of as per the report says.
So what type of algorithm have you used, sir?
I have my own algorithm, and that means the name of the algorithm is VM placement algorithm. By using this algorithm, we have to effectively, first of all, you have to check the threshold value of the physical machine. We have to fix the threshold value for each and every physical machine. If it is the threshold value is 30 to 90, 90 is the upper threshold limit, 30 is the lower threshold limit. If it is go down, it will be migrated. If it is go beyond the limit of 90, at the time we can migrate the virtual machines, so that we can utilize the physical machine in correct manner, as well as power efficiency also increase. That is the concept. As well as the report says, McKinsey report what says means most of the data center servers are in underutilized mode. If you are going to focused on the underutilized machines, we can save more power as per the report says of McKinsey.
Thank you, sir. Thank you very much.
Sir, how will you fix the threshold value, sir? Because you told that 32 to 90, the range of the threshold. How will you fix the threshold value, sir?
Ma'am, it will be based on some of the previous methods and experiments what we have to focus. So depend upon the methods and algorithms and studies of previous things, we have to fix the threshold value limit. 30 and 90 is just to say as an example, but it will be depends on the some of the studies and some of the methods what we have to apply earlier.
Okay, sir. Is there any tool present for fixing the threshold or for energy saving, power saving methods?
Methods, tool, madam, tool.
Yes, sir.
Cloud SIM is one of the efficient tool for this. Cloud SIM.
Cloud SIM. Yes,
The
sir.
green cloud is there, but in my research work, I have to use cloud SIM because of the cloud SIM is it was developed by the Rajkumar Bhaiya. He is the father of cloud
Mm.
computing.
Cloud
He is in
computing. Yes,
Melbourne
sir.
University. It
Mm.
was developed by himself. It will be only used for this power consumption as well as the power resource provisioning concept. That's why it is a very suitable for the power consumption as well. If you are going to do the research, if you are going to do the research on resource provisioning, you may take the cloud SIM as a super.
So is it Cloud SIM is an open source or licensed version?
Open source. Yeah, open source.
Open
Will be
source.
available in
Okay.
Google.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Sir,
Yes, sir.
apart from cloud SIM, whether there are any other tools or simulators available for doing research in cloud computing?
Yes, a green cloud simulator, green cloud simulator is which is also used for the resource provisioning as well as the power efficiency. Green cloud.
Okay, thank you, sir.
Hello, sir.
Any other questions?
Yes, hello, ma'am.
Yes, ma'am.
In this pandemic situation, what is the role of this green computing technology? Because continuously we are using this computers and all for continuously in pandemic situations.
We have to reduce the working time of using the computer. That is one of the solution. We have to reduce the time of because of most of the people stand using the mobiles and computers in more time. So we have to reduce. That's one of the thing. Apart from this, I don't know what are the alternate solutions.
Okay, sir. Okay, thank you, sir.
Okay.
Participants, any questions? Thank you, sir. Thank you for your wonderful presentation.
Thank you, madam. Sandil Kumari, madam. Thank you for your opportunities.
Thank you, sir. Thank you.
Sister Mary. Thank you, madam. Thank you.
Sir,
Yes, sir.
I would
Thank
like
you,
to.
sir. You're also more than a brother to me.
Yes, ma'am. His brother, Mr. Balamurugan, is very close to me. Thank you, madam.
Thank you, sir.
So shall we move the formal?
Yes.
Yeah. I would like to call Ms. B.A. Hadjat Magira, Assistant Professor, Department of Computer Science, to share the feedback of today's session.
Good evening, sir. It was a very useful session to us. The content that you have delivered really opened up our minds about cloud computing. Surely we were able to learn service models, power management in cloud, and many more things are there to list out. You make us very clear on green cloud computing, sir. Thank you, sir. Thank you so much for sharing your precious knowledge with us. Thank you.
Thank you, madam. Thank you very much.
Thank you, ma'am.
Thank you.
The roots of all goodness lie in the soil of appreciation for goodness. I would like to call Ms. K. Anshila, Assistant Professor, Department of Computer Science, to propose the vote of thanks.
Thank you, ma'am. A very good evening to one and all. It's a privilege and a great honor for me to extend a vote of thanks. First of all, I would like to extend my thanks to the Almighty for making this occasion a success. Next, I wish to express my deep gratitude to our management and respect the principal, Dr. S. Sumaya, for her continuous encouragement and support. Then I wholeheartedly thank to our director, sir, Dr. M.S. Irfan Ahmed, for his continuous guidance and support. Thank you, sir. I am very much thankful to our head in charge, Dr. P. Sandil Kumari, who has been the driving force behind the whole process. Thank you, ma'am. I am very much thankful to our resourceful resource person, Dr. R. Karthikeyan, Professor and Head, Department of Computer Science and Engineering, Muhammad Sadak Engineering College, Kilakarai. We are really enlightened with your knowledge. The way you should share the topic is exemplary about cloud. Thank you for your invaluable contribution. Thank you so much, sir. Finally, a big thank you to all the participants who have attended this third day of FTP. What is learned here would have been a direct implementation of our future. Once again, thank you all.
Thank you.
Thank you,
ma'am.
sir. Thank you for your cooperation.
Thank you. Thank you.
Thank you, sir. Thank you for your active participation and cooperation. Once again, I thank you all. Kindly fill your feedback form, which is in WhatsApp group.
Yes, ma. You can close the session.
Thank you, ma'am.
Thank you, Ananda.